Okay, we're going to be talking about solving 2D momentum problems. So the first thing is recognizing it is a 2D problem. And the answer to that is pretty simple. It will either give or ask for angles between motions of objects. If you see a question that's talking about the angle between two things being different than 0 or 180 degrees to start with, then it's going to be a 2D momentum problem. If you see something where it's asking for the angles that things end up at, it's going to be a 2D momentum problem. Usually those things are enough to key you in on it, but yeah, keep an eye out for it, because this is the single most common mistake made when doing 2D momentum problems, is treating them as though they're 1D momentum problems. So just don't do it. If you see any signs that it's going to be a 2D momentum problem, then don't use 1D momentum methods. All right, let's see some other things about it. Well, 1D momentum problems only have one equation or two with elastic. 2D momentum problems have effectively two equations, or even three if full 3D, but we're really just talking about 2D here, or three equations with elastic. On the other hand, 2D momentum problems have 10 total parameters versus 6 for 1D momentum problems. So they get quite a bit more complex in terms of the things you might need to know. So basically you need to know the masses of each object, or maybe that's what you're trying to find. You need to know the initial velocity, which means magnitude and direction, or components, to each. So there's 2 for V1 initial, 2 for V2 initial, 2 for V1 final, 2 for V2 final, and then the two masses. Total of 10 parameters there. That does mean you need to be given a lot of information before you have a solvable system. So a thing to be aware of, you've got to know a lot of information to even launch into one of these. All right, let's imagine how this gets set up. We have a mass 1 and we have a mass 2, and they're moving. So m1, m2, and maybe in this case they're kind of moving towards each other. So v1 initial, v2 initial. After the collision, their motions will change. V2 may find itself going, I don't know, straight up even, or mostly up. V1 may be barely moving along, but you're going to end up with some kind of motion V1 final and V2 final, some combination. All right, what does this result in? Well, you can try writing it as a single vector form problem if you know components. So m1 v1 initial is a vector plus m2 v2 initial as a full vector, x and y components I hat j hat equal to m1 v1 final as a vector plus m2 v2 final as a vector. How is this two equations? Well, it's two equations because in general we would split that up into conservation of momentum in the x and y directions as separate things, because they do need to be both conserved simultaneously in order for the vector form to be conserved at all. So you'd get an m1 v1 initial cosine theta 1 initial. This is an m2 v2 initial, that's now the speed, cosine theta 2 initial. That would be equal to m1 v1 final, the final speed, cosine theta 1 final, plus m2 v2 final, again that's the speed, cosine theta 2 final. So here you can see a lot of the parameters. We've got the masses, we've got the speeds, initial and final, and we've got the angles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 total parameters. the same parameters show up in the y equation. m1 v1 initial sine of theta 1 initial plus m2 v2 initial sine theta 2 initial equals m1 v1 final sine theta 1 final plus m2 v2 final sine theta 2 final. Okay. If elastic, then you also get 1/2 m1 v1 initial squared, that's the speed squared, plus 1/2 m2 v2 initial squared equals 1/2 m1 v1 final squared plus 1/2 m2 v2 final squared. Okay. But only if elastic for that last one, so don't use it all the time. Usually we don't use it in solving problems at all. We'll talk about what happens with elastic separately in a minute or so here. This is what you want to do. You can rethink things and think about this as m1 v1 final in x. Okay, that's for the momentum in x equation, and m2 v2 final x. Same thing with v1 final y and v2 final y on the other side. So why would you want to do that? Well, sometimes you don't care about the angle, you just care about the speed, and you could just find the components, square them, take the square root after adding them together, and get the speed. So this is two different ways of thinking about the equations. You can do it with just straight up components, or you can use the angle to find parts. All right. More important points when you're trying to solve these problems. Frequently, problems will just say that the angle between the objects to begin with is some angle. What you want to do in that case is pick one object, put its motion along the positive x or positive y direction, then place the other object moving relative to that. So it might say, oh, there's an angle of 30 degrees between their motions, but they don't tell you what the motions of each are. Well, that means you can take your mass 1, put it moving along positive x, and then take your mass 2 and set it up so it's coming in at an angle of 30 degrees, and that would set you up to solve the problem. Okay, last thing I want to talk about related to all of this. If the masses are equal and the collision is elastic, and one object is at rest, then the angles between their final motions will add up to 90 degrees. You're not getting this knowledge for free, by the way. I have a problem on your homework where you actually have to prove this. And that problem is carefully written. It walks you through it step by step. Do nothing extra as you're doing it. When it says set up the px, set up the py, just do that. Just set it up. Don't rearrange, don't move anything. You can cancel the masses. You can cancel the 1/2s in the kinetic energy equation when that shows up too. The second part has you squaring both of those equations. Don't move anything across the equal sign, just square them. The next one will have you doing something with kinetic energy and adding all the equations together. Some really cool stuff happens there thanks to some trigonometry rules. To mention specifically the trigonometry rule you will need, it is that sine squared theta plus cosine squared theta is equal to 1. That will let you clean up a lot. Then you'll also need the angle addition formulas. I'm pretty sure I mentioned them before, but if I didn't, Sine of a plus minus b is equal to sine a cosine b plus minus sine b cosine a, and vice versa for cosine a plus minus b, it's equal to cosine a cosine b minus plus, that's important, sine a sine b. Okay, that should give you what you need to figure out the answer for that. These problems are harder than the one-dimensional ones, but they're still quite doable, and you are given a lot of information when you start one. So be careful, try the homework problems, try the practice problems. I think you'll figure them out. And that's going to be it for this video.